So today we're going to be looking at how to solve trig equations that don't have a normal period. And what I mean by that is if you take a look at this equation that I have here, we see that there's a 3x in there. If you recall from a previous lesson, we talked about how the graph of this function would basically be, if we see an amplitude or an a value of -4, we know that the sine graph would be going down like this. And the thing about this is, because we see a 3 here, we're going to have 3 sine graphs occur within a normal period of 2 pi. So we know that right here, that's going to be the value of 2 pi. So the question comes into play then is how many solutions we're going to have. Now, because we have 3 of these sine curves occurring in one normal period of 2 pi, what we see here is that if we want this equation to equal 2, we know that this has a maximum of 4 and a minimum of -4, then having that height of 2 will mean that we're going to have our graph intersect this line at y equals 2. And notice how many times it intersects. It intersects 1, 2, 3, 4, 5, 6 times. So when we solve this equation, we're going to end up with 6 answers. So let's go ahead and solve this algebraically and see how this is done. So the first thing we're going to do is, as we do with the previous trig equations, we're going to isolate our sine, our trig function. So we're going to get sine of 3x is equal to 2 over -4, or we know that's the same thing as -1/2. So the question you're asking yourself then is, when does sine of 3x equal a -1/2? Well, recall, at this step, this is where you want to be thinking, on my quadrants, when is sine going to give me a negative value? And sine gives us negative in quadrant 3 and quadrant 4. We know that based on our unit circle values, that's going to give us a reference angle of pi over 6. So therefore we know that in quadrant 3, the 3x is going to give us the radian measure of 7 pi over 6, since we are in quadrant 3. And also, we'll get that 3x is equal to, in quadrant 4, we'll have 11 pi over 6. Now, keep in mind that really the 7 pi over 6 and 11 pi over 6 was really just giving us 2 values, but we want to find 6. Now, where are those 6 coming from? Well, keep in mind that, that the sine just keeps going on and on. We're going to find coterminal values that give you the equivalent spots. So to find coterminal values, what you want to do is add on another 2 pi n to your answer. So we add 2 pi n to these answers here. Okay? And then we solve for x by dividing everything by 3. So here x is equal to 7 pi over 18 plus 2 pi n over 3. Same thing over here. We get x equals 11 pi over 18 plus 2 pi n over 3. Now, in order to make our lives easier, just in terms of getting our answer, it would make sense to actually get these fractions into common denominators. So I see that my common denominator is going to be 18, so that means just multiplying this fraction by 6 and 6. And same thing here, 6 and 6. Meaning what I really have is 7 pi over 18 plus 12 pi n over 18. And similarly, we have 11 pi over 18 plus 12 pi n over 18. From here, we just find all of our values. First of all, when n is 0, we're going to get a value of 7 pi over 18. And then for this case, when n is 0, you're going to get 11 pi over 18. For the next answer, when we go in the find the next coterminal value, when n is 1, we're going to add 7 plus 12, so we're going to get 19 pi over 18. And in this case over here, when n is 1, 11 plus 12 is going to give us 23 pi over 18. If we go a little bit further, we do n equals 2, we're going to add another 12. So 19 and 12 is going to give us 31 pi over 18. And then over here, if n equals 2, we add that 23 plus 12, and we'll get 35 pi over 18. Okay? Now, one thing you want to be aware of is that you have a domain restriction from 0 to 2 pi. So we want to make sure that we do stop right before we hit 2 pi. Now 2 pi is equivalent to 36 pi over 18, so just make sure you don't go beyond 36 pi over 18. And it looks like all of these answers are within 0 to 2 pi. So notice here we have 1, 2, 3, 4, 5, 6 answers. Those are going to be your 6 answers that relate to each of these spots right there. Okay, so that concludes our first example. Let's go on to the next one. Okay, so for our next one here, we have solve again for the restriction from 0 to 2 pi. We have our equation 2 cosine 3x. Recall what that means. That means that you have a graph of cosine, and the thing about cosine is you're going to have 3 of them. 1, 2, 3 occur within one normal interval, one period of cosine of 2 pi. So you got 3 of these graphs. Basically your graph got condensed so that you have 3 of those graphs occur. It also has a amplitude of 2, so 2 and negative 2 right there. And we want this value to equal square root of 2, which is about 1.4. So what we're saying is, when does this graph cross the value of 1.4? And we see again it occurs 1, 2, 3, 4, 5, 6 times. So in our final result we should end up with 6 answers. Okay, so let's go ahead and solve this algebraically. First thing to do is get your cosine of 3x isolated, so we have root 2 over 2. And at this step, remember, when does your trig function give you a positive value here? Well, because it's cosine, we know that cosine is positive in quadrant 1 and also quadrant 4. We also know that root 2 over 2 is giving us a reference angle of pi over 4. So now what we can say is that 3x is equal to, in quadrant 1, we've got pi over 4. And 3x is equal to, in quadrant 4, we know that's going to give us 7 pi over 4. Keep in mind you want to find all coterminal answers because the graph got squished. You have 3 graphs occurring where normally 1 graph would occur. You got to make sure that you find all coterminal values. So add 2 pi n to each of these values. This is the big piece behind today's lesson, just making sure that you add 2 pi n to find all possible answers. Okay, so if we solve this, we get, oops, let me erase that. X is equal to pi over 12 plus 2 pi n over 3. And over here, we're going to get x is equal to 7 pi over 12 plus 2 pi n over 3. Again, let's get common denominators like we did in the previous example. And so we'll just multiply this by 4 and 4, and also over here 4 and 4. So this will turn into pi over 12 plus 8 pi over 12. And over here we're going to turn this into 7 pi over 12 plus 8 pi over 12. Oops, I forgot the n. Okay, alright, so let's find all of our values. First of all, when n is 0, we're going to get pi over 12, and we'll also get 7 pi over 12. When n is 1, you're going to add 8 pi over 12, so 8 and 1 will give us 9 pi over 12, and over here when we add 8, we will also get 15 pi over 12. While we're at it, that's the same thing as 3 pi over 4, so we'll just reduce that. And over here, 15 over 12 will reduce to 5 pi over 4. Okay, so those are going to be technically our reduced values there. Alright, and then let's do another one, n equals 2. When we add another 8 to our value here, keep in mind it was 9 pi over 12, so if we add 8, we're going to get 17 pi over 12. And over here, when we do 15 plus 8, we'll get 23 pi over 12. Just verify, you want to make sure you don't go beyond 0 to 2 pi. Now 2 pi is technically the same thing as, since we're doing over 12, 24 pi over 12. Just make sure you don't go beyond 24 pi over 12. You don't want those as your answers. And currently we see 23 pi over 12. That's going to be our limit, because 23 pi over 12 will take you right there, really close to 24 pi over 12. So we'll end it there. These are going to be your, again, 6 answers. Alright, this last one that we're going to do is a little bit different. We're going to see that this doesn't give us a nice unit circle value, right? We get 1/8. So this one will require the use of a calculator. So make sure you have your calculators out for this problem here. Alright, but the same rule applies. Basically, we're trying to find when does cosine 2x, keep in mind what that means, you've got two cosine graphs occurring within a normal period of 2 pi. It has an amplitude of 8, and we're trying to see when is this equal to 1, like that. So you should get a total of 4 answers then. Okay, you want to see that it crosses that value of 1 4 times. Alright, so let's go ahead and do this. It requires a calculator though. We're going to need to do the arc cosine of 1/8, right? If we want to solve for x. Alright, so let's get our calculator out. And we're going to do arc cosine of 1/8. And that's a value of 1.445. I'm going to store this answer as A, just so that I have this in mind here. And then I'm going to go back. Good. And so this value was giving us 1.445. Okay, but one thing to remember, whoops, I forgot to do it here, is when I have cosine, it's giving me a positive value here, and positive values occur in quadrant 1 and 4 for cosine. So what I know is my reference angle is 1.445 here. Well, I gotta find the other angle too, the one that is in quadrant 4. And how do I do that? Well, it's like a full circle, but then if this angle is symmetrical to this angle, then what I need to do is 2 pi minus 1.445. Okay, so I'm going to have 2x is equal to, let's find that value, 2 pi minus 1.445. So 2 pi minus, let's do second answer, and I get 4.837. I'm going to store this value as b. Okay, so that way my calculator has both values, a and b. Okay, I'm going to go back, and that value was 4.837. Bring this back. Okay, so this is 4.837. I'm just going to make a mental note to myself that this value here was A and this value here was B. Just so I remember when I want to enter that into the calculator what those were. Alright, so one thing to remember is, that this graph it had gotten condensed, so you want to make sure you add coterminal values, 2 pi n, to get back to the same spot on the unit circle. Alright, now the thing about this is, if we're solving for x, you got to divide everything by 2. So I have to take this value of a, 1.445, and divide it by 2. Same thing with this one. I need to take 4.837 and divide it by 2. So since I already have this in my calculator currently, I'm just going to go ahead and do this one first. 4.837 and divide it by 2. So here it is, 4.837 divided by 2. That's going to give me a value of 2.419. 2.419. Okay, so we have 2.419. That's what it was. Plus, and then divide by 2, I'll get pi n here. On this side, I need to do 1.445 divided by 2. Basically, that was the value of a. So, alpha a divided by 2. And that looks like it's 0.7227. Okay, so this is 0.7227. Plus, and then again, when I divide this by 2 over here, I will get plus pi n. Alright, so now we can find all of our answers. Keep in mind, first of all, when n is 0, you have the first answer of 0.72, and I'll just round it to the nearest thousandths, so that'll turn into 723. That's my first answer. Over here, I also get my first answer of 2.419. Okay, that's when n is 0. Now I find my next one, and n is 1, so I'm doing 0.723 plus pi. So I do 0.723 plus pi, second pi, and we get 3.865. 3.865. That's our next answer. Okay, so we get 3.865. Just keep doing this. You have 3.865. Let's add on another pi. So plus pi again. Oh, look at this. 7. This is way out of bounds. Remember, we want to be between 0 to 2 pi, and 2 pi is 6.28. So if I add another pi, I'm going to be way out of bounds. I don't want this answer. So let's actually go back to the other value, the second answer. Okay, so what we have now is these two answers, for sure. And then now let's add on another pi to 2.419. And that'll do it. 2.419 plus pi. 5.56, that's all right. 5.561. 5.561. Okay, and those are our answers. Okay, and that'll do it. So we have 1, 2, 3, 4 answers, and notice on our graph we have those 4 answers that you see there. Okay, all right, that'll do it for today.